I received a box. And we all know what that means. We've got some goodies. Greetings, the Astro 30 here with another video. A patron of mine sent me this package a couple of days ago, and I just received it today. I know what it is, and you can probably tell from the title what it is, but it's going to be something very interesting. Now, I've already gone ahead and opened the box because it took me about 5 minutes to cut the bloody thing open. There was so much tape on it, so I've already had a look inside. So I know what's there. I got me some vino to drink. Actually, it's lemonade. No, honestly, I swear, it is lemonade. Anyway, crap drink aside, I'm going to take the contents out of the box and we're going to have a good look at it. I've got to be careful because there's a padded bag inside with the actual guy's real details, name and address and stuff on it, so I don't want that to appear on camera. And just so everybody knows, it's thanks to Danish Dart for sending me this. He sent me that multimeter last year, which I still have right here, and it's served me well. I haven't even replaced the batteries in it yet. So let me just get this out of the way, turn it upside down. We have a padded bag from DigiKey Electronics. Well, where this came from didn't come from DigiKey. He's included two, I'm not sure why two, but two largish aluminium brackets, L-shaped ones, and that's like 5mm thick aluminium. That's pretty substantial. We'll see why these are necessary in a minute. So in the bag we have a bunch of components. So it's bag within a bag. There's a bag of, I'm not sure what that is, transistors I think. Yep, these are transistors, MJE 340 and 350 respectively. They're going to come in handy for something. You'll see why in a minute. So something else in the bottom of this bag. Two N-channel MOSFETs. These are IRFP 260Ns N-channel MOSFETs. A bunch of BC 546 and 556 respectively. And in this bag we've got more components. Looks like a kit, doesn't it? Well, it kind of is, kind of isn't. Some seal washers for the MJE style transistors. He did say that he didn't have any for the MOSFETs, so I'm going to have to get some of those. That's fine. We've got some Hytono 3300 microfarad 63 volt capacitors, 4 of them. They look like board standoffs. We have a rectifier PCB I should say. I'm not sure who this came from, like who made it. It's a fairly high powered one, requires 10,000 microfarad capacitors, and they've got bleed resistors and LEDs on each rail in order to help discharge the caps quicker. A nice beefy full bridge rectifier. Yeah, anyway, and finally, this is what we came to see, the ElectroIndia power amplifier. It's supposed to be an N-channel MOSFET design which is capable of 200 watts. Apparently the power supply rails for this are supposed to be in the order of about 120 volts DC with a center tap. I'm not going to run it anywhere near that power. because these caps are only rated at 63 volt, and if you put a 45045 volt transformer on it, on that power supply, that equates to 126 volts DC. So that's, well, 64 volt, no, 63 volt across these caps, and they're only rated at 63, and you'll blow the arsehole clean off of them. I remember a time I built that test amp a few years ago, and one of the capacitors was rated for 25 volt. There was 24.5 going into it, and it just blew the arsehole off of it right in my face. Anyway, that's beside the point. So what we're going to be doing is, over the coming next few videos, I'm going to be building this little PCB. At the moment, this is just the introduction. I'm going to review this PCB, and in a second we're going to look at the reverse engineered schematic that I've got for this. I spent 2 hours on Sunday reverse engineering it, so we now have a schematic to look at, and then I'll go through some points about what I think of this and the schematic itself, and yeah, then we'll go from there. So I don't have a lot of room on this desk like I did on my old one, but we'll just have to work with it. This is the schematic. I've set this for plus minus 45 volt. I think that's a much safer voltage to operate that at, which is a 30 volt AC transformer, and you're going to require around about 5 amp for the modules. Now, it's a very typical Class AB amplifier design. Here's the input stage, 2 NPN transistors, BC546s, and we've got a current mirror up here on the positive rail, 2 PNP transistors, BC556s. And the great thing about this design is there is a DC offset adjust between the 2 emitters of the input stage. So you can actually get your output DC offset as close to zero within, 10 millivolt or so, plus minus, to zero, so that you have no DC on the output. It helps balance the input stage, and it's a pretty typical design. Down here in the emitter circuit, I found quite interesting. We've got this constant current source, which is formed by this NPN transistor, this 220 resistor, a 10K, a 22K, and these 2 diodes. Now, on first glance, this may appear weird because we've got 2 diodes here. This is the negative rail across here, and it's basically reverse biasing this transistor off. Now, you'd say, well, that can't work. However, I have seen constant current sources that uses an LED in the correct polarity, so it actually lights up on the board to do the same thing that these 2 diodes are doing. I apologise for the focus. It's doing the same thing as the LED is doing. It's basically controlling the amount of base current that's here. Basically, this resistor, 22K, and these 2 diodes, they are in essence forming a voltage divider. So this is our negative feedback here, and we've got a 27K and a 1K, and that's going to set the gain to roughly 28. So that means about 1.2, maybe 1.3 volt peak to peak input signal is going to give us full output swing, theoretically speaking. Over here is our VBE multiplier. It's a pretty standard arrangement. And over here is the VAS coming off the collector of the first transistor. Now this is a PNP. This is hand drawn in because when I was reverse engineering I forgot to include it. Happens. So that's why that's there. I'll fix it up on the printed schematic later and make sure that that part is included. Then that goes into our driver stages, which are MJ340 and MJ350 respectively. Standard Class AB driver setup. Finally into our N-channel MOSFETs. There's one there and one there. Now, one last thing about this bias adjustment, just so in case anybody wants to know. The way we set the bias on this one is we measure the voltage drop across either one of these resistors here, these 5 watt ones, the 0.33 microfarad, 0.33 ohms. If I could speak, that'd be nice. Measure the voltage drop across there, and we adjust this trim pot so we get a reading on our multimeter in the millivolt scale of around 10 millivolt, which will give us roughly a current flow on the output stage here of roughly 30 mA. 30 to 50 mA is fine, because in the ElectroIndia video they didn't actually go through any of the setup. They didn't adjust the DC offset, and they definitely did not adjust the bias, so that information wasn't sent on to the viewer. So there's no schematic for it except this one that is available, and there's no instructions about anything except how to put components on the board and solder it. That's about it. Now at first glance it looks pretty well made until you turn it over. There is an awful lot of large copper traces. A lot of them really close together. Now, as a layout of a power amp goes, this has got to be probably one of the most piss poor layouts that I have ever seen. Whether this is going to be prone to high frequency oscillation, I don't know without putting it on a scope. It could work just fine, but you've got the power rails real close to the signal rails, because there's the input signal in here, and you've got a power rail. Well, that's the ground reference, but you've got a power rail running around here and a power rail running around here. And then there's these high current lines coming off of the, I think that's the drain of the MOSFETs, going all around the board here. It's like, why? It's just way too much copper. And secondly, there is no provisions to mount this to anything. You can't mount it to the heatsink bracket. There's no screw holes. There's no screw holes anywhere to help facilitate mounting this into anything. Because what they plan on making you do is you take your bracket like that, and you basically bend the transistors over, drill holes in here, and the whole thing is just held up by the transistors. Yeah. Okay, that's real intelligent. That's really piss poor design. I do have a use in mind for this, but what I'm going to have to do is make a modification and drill 2 holes for mounting screws. I'm going to do it on the ground plane, which is the best place to do it. Probably one there and one there, far away enough from components. So I've got somewhere to mount it. I'm not going to just rely on the transistors. I'm not going to use that either, even though it's a nice piece of aluminium. I've got a different idea in mind. And I'm going to leave it in the comments section below for you to sort of like guess what I'm going to be using this for. If you've got a guess, give it your best shot in the comments, and I will let you know in time. I'm not going to say anything more now. I'll let you know in time what my intentions are. But I do have to make some form of mounting for this, because I can't have it just free floating around like this. It will just end up damaging the board. Especially if the amp's sitting near a speaker, the vibrations from it will eventually either crack the solder joints on the transistors or the actual leads of the transistors themselves. So yeah, that is a pretty big shame that they didn't think of that. One other point of interest with this schematic that I forgot to mention is they've got a free floating earth arrangement here. So they've got a 10 ohm resistor going to the ground reference to this negative input, or the ground input for the input signal. Now, if this is used internally with its own preamp, you don't need that. You can just omit that and just put a wire link on the board. This is for interconnecting external equipment to it, so that you don't introduce ground hum loops into the external equipment or vice versa. That's what the attempt of that is for. Blah 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 blah. Your mama was a snowblower. Blah 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 blah. No idea what that means. Yay! Yeehaw! Yippee-ki-yay, mother! I was talking to Danish Dart on Patreon messages, and he was saying something. He was a bit worried about these transistors pinouts not being correct or something. I think he's mainly alluding to fake transistors. That might be what he's concerned about. Now, the pinout of the MJE series and the BD series of this type of case is base, collector, emitter. Collector's in the middle always, emitter's on the left, and base is on the right. Now, which one's this? Is this the PNP or the MPN? That one is the 340, so that's the MPN, so it should be positive base. So what I'm going to do is I'm going to bring in this on diode test, positive on the base. We've got a close to 0.6 of a volt drop there, the emitter, close to 0.6 of a volt drop there, and nothing in reverse, nothing in reverse. Great. So there should be nothing across the collector emitter either. Nothing. I believe in Darlington you will see something across the emitter and base. No, the emitter and collector. I'm not sure now. Anyway, that transistor checks out fine, and we'd have to assume that the pinout is correct, that it's base, collector, emitter. I'll test another one just for shits and giggles because, well, I've got them sitting here, so I might as well. I've got nothing else to do at this time of night except drink piss. Because there should be a PNP version, if I can get it out of the bag. That one is the PNP, that's the 350. So it's going to be a negative base. .6 of a volt drop close to it. Whoops. Get on there. Actually, almost exactly 0.6 of a volt drop. So check it in reverse conduction. Fine, fine. So they're not shorted. I mean, I could sit here and test the other two. I mean, well, I can do. Which one's this? That's the other three. Is that 340? Yeah, 340. Watching the Astro 30 test transistors. It's wonderful, isn't it? Fine. Lucky last, the last 350, there's two of them and two of the MPN respectively, so that's negative base. Fine, 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 and fine. All good and dandy. So yeah, that's the ElectroIndia power amplifier board. New little project that I'm going to be working on over the next coming months. I'm going to say now that it's going to take me a while because I don't have any of my test gear or soldering equipment. It's all in storage. I don't know when I'm going to be getting any of that back, so I'm going to have to start start by getting a soldering iron so I can put this together. Got to work out some form of transformer for this too. And I've also got to find something else to help this project along. So I really need an oscilloscope. If someone wants to donate me one of those cheap handheld oscilloscopes, DSOs, feel free to. You can do that on Patreon. No, seriously though, but if you want to become a Patreon member, please do. You can pledge as little as $2 a month USD. Any people that become my patron, that little $2 donation, if you want to call it that, does help a lot. So it'll help me buy equipment and stuff that I need to make projects like this, because I really need to get back into doing home electronics. I haven't done it in a few years. The videos you're seeing uploaded to YouTube before, especially that mixer preamplifier project I was working on, that's at least a 3-year-old video now. So there's that. There is one other thing I need to mention about this board. I will link the ElectroIndia video in the description. Oh, I just farted. It is in Hindi. Oh, excuse me. It is in Hindi, but they did say, from reading the English subtitles, there's 2 jumper wires here that you've got to connect if this is the single-sided version of the board. All it's doing is it's connecting the positive rail over to here. But there's 2 red traces on top of the board here, which I believe will be electrically connected, because this would be a double-sided board, and actually the quality manufacture of the board is good. The layout is shit, but it is what it is. And it probably, as I said, works just fine, but that remains to be seen, because I haven't actually tried it yet. Right, continuity. Yes, I'm using your multimeter, Danish Dart. Thank you very much for that again. Yep, they're electrically connected, so you don't even have to worry about them. It's kind of a pointless endeavour. I mean, that's all that's on the top layer is those 2 traces, apart from the through holes, of course. What a waste of a top layer. Personally, and I hope ElectroIndia sees this video, personally, I would have routed this PCB a little bit differently. I would have put all the low current stuff, like all the routing of the low current stuff, on the top layer of the PCB, and all the high current stuff, like the output stage transistors and the power rails, on the bottom. And maximize the copper that was on top of here before it got eaten off and left behind just these little 2 traces, and the pads, of course. So yeah, that is pretty disappointing to see people do things like that, and especially all these large traces. That's totally unnecessary. And just one thing, if you're going to be running this at the suggested power rails of 63 minus plus voltage, I would expect a lot more than 200 watts into 8 ohms coming out of it, just saying. Probably more closer to 3 or 4. But I don't need that much power anyway. But that'll be something that we'll be building over the next coming weeks, and this video is going on for a million years, so I'm going to stop talking now because I want to drink my wine, and I can't do that whilst talking to you. So anyway, back to Patreon. If you want to become my patron, you can do so for as little as $2 a month, as I said. The link is in the description below. It's totally up to you. I'm not forcing you, you don't have to, but it'd be nice to have a few more patrons on my Patreon account, and I'll try to bring much more exciting content like this of unpacking a box and looking at a PCB and doing absolutely nothing with it. Anyway, I'm the Astro 30, and I hope you enjoyed this video, and I hope you're looking forward to this multi-part series on this in the next coming few weeks to a couple of months, because I am. And I'm actually looking forward to getting back into doing something constructive. Anyway, I'm the Astro 30. Thank you for watching, and please remember to like, comment, rate and subscribe below. Anyway, this is Astro 30 saying see ya. Happy power amps. No idea what that means.